The amount of Coca-Cola in a bottle can be modeled as a normal distribution with a mean of 500 ml. The bottles with the top 25% of volume start from 520 ml. What is the standard deviation of this model? Again, the first thing as always is to actually get to the normal distribution part in your calculator, and it's the inverse normal here because you're trying to find something about the data using some probability that you already know. So again, we go to stat from the main menu like this. We go to distribution F5, click that. Normal F1, click that. Inverse normal, click that. F3, and now you're at this screen. Now again, the second thing you always do is try to visualize a diagram, try to see what you actually are seeing. And the biggest thing to note here is the top 25% is what we're looking for. So it must be the right side of the data, and the area under the curve must be 0.25 because that's the percentage that we have. And the graph should look something like this. Right? However, we don't know the SD here for this graph, so we don't really know how wide the graph should be, relatively speaking. Again, we know we're finding the red area. I know that the mean is 500 ml, and I know that blue line there must be at 520, but I need to know the SD exactly. So what I actually do for this is I actually look for the standard normal distribution, find the z value, and then I have to go back from the normalization process to find what the actual number should be. So what we do for this is that we input the values for a standard normal distribution in a calculator. And a standard normal distribution has always got a mean of 0 and a standard deviation of 1. So I'm going to put those into the calculator. Thankfully, those are already there. Generally, they're always there. Now, again, we are looking for the area with the tail to the right because it's the right side of the data. It's the top 25%. So we're going to make sure that the tail is set to the right here and the area is set to 0.25 like this. If we go down, we'll see that, right? When we click execute, we're not going to get the actual bound itself quite yet. We're going to get the z value that would correspond to that bound. And after that, we'll need to use some algebra to find what the answer should be. Now we go down, exit, and then execute this. Gives us the z value of 0.67448975. Because we haven't finished the question quite yet, I would recommend keeping this exact value as it is to all the decimal places you've been given to keep it as accurate as possible. And we go down and we see that z is this. Now what we do is plug this into the normalization equation like so, which is z is equal to x minus mu over sigma. This x here is the bound that we'll be after, or the number that's away from the mean that we are interested in. The mu is the mean that we already know, and the sigma is the standard deviation that we need to find. As we see, this equation should look something like this. You plug in the numbers. Z is this value that we already had. 520 is the bound that we already knew. The mu is 500, and the sigma is the standard deviation that we're needing to find. 520 minus 500 is 20, so that's where this 20 comes from. And it looks like a fairly standard one-step equation at this stage, 1 to 2 step equations. We replace the sigma with the values by sort of cross-multiplying them. And then this is now a calculator problem, so we chuck this in the calculator. We get 29.652044378. That approximates to 29.65 ml to 2 decimal places. And now we have a final answer that the standard deviation of this model is approximately 29.65 ml.